and we're going to get started. So, this is session 3 of our iReady Caregiver webinar series. This is the last one, at least for now. I have a survey at the end to see how people are feeling about these and if they're interested in continuing things like this. But maybe you're one of the people that took the survey where we said, as families, as caregivers, that we wanted to learn about the digital experience my students are having on iReady. We want to learn about the instructional framework that iReady is using. And then Math Manipulatives is our last session this evening. So welcome, everyone. I am Lexi Vandenhoevel, so if we have not had the opportunity to meet, I'm the district's math coordinator. And so I get to work across the entire Sun Prairie system, 4K through graduation, which is really exciting. I spent most of my educational career as an elementary principal, 8 of those years, total years at Northside Elementary. I have 3 kids, 2 of which are still in the system, one that just graduated, and I get to work with all of our amazing educators in the system. So part of my work is also to reach out and partner with you all, especially since we just adopted and implemented a new 6-8 curricular resource. So your students are all learning with iReady, and we want to make sure that not only are our staff and our students getting access and learning about what this resource offers, but also wanted to partner with families so that you felt like some of this has been what's happening in my child's classroom and I can understand what's going on there, but also helping you to understand how you can support at home as well. So that digital learning experience, a little bit of that. And then Math Manipulatives today also could be an opportunity for you to understand and support more on the home front as well. So again, a little bit of a brief review of that iReady experience and some things we've already talked about. We have a diagnostic assessment our students are taking 3 times a year. They just took their second round a little bit ago, and that helps us to really understand where our students are at. It is based on grade level standards, and so it helps for teachers to really map the strengths and the needs of their students, and also then provide some really strategic, specific lessons and moves that teachers can make to support their learners. It also comes with a work text or a workbook that students are using in the classroom, and they can follow along with the daily learning that's happening in those lessons and do practice problems. And then also that digital learning experience. So your child might be playing with MyPath. They might be doing some different learning games. They can also access their book online at home with you if they're struggling with something or want to talk to you about something or show you what they learned in math. And in there as well are some family resources. So that's that sort of comprehensive, robust iReady classroom mathematics experience that we are using this year for middle school. And next year we'll begin K-5. So we'll have it K-8, bringing some continuity for our students and you as families, as well as our staff. The structure of the lessons are about a week. And so we have talked before around how students are exploring what we're gonna learn about. Teachers are able to dig in and really make sure that kids have the prerequisite skills they need to access that new grade level learning for the week. And then all of those lessons close out with what they call a refine day, where teachers are able to really assess how students did, and then pull small groups and make sure that everybody is getting what they need out of that learning that week. The framework we talked a little bit about in session 2, and I'll share all of those session recordings out when I share this recording, was the framework that our instructional model uses, which is this try, discuss, connect. So we really want to be able to have students individually thinking and making connections about the math that they're trying and learning about, talking with their peers, hearing other strategies, comparing strategies, and then teachers are really, really thoughtfully listening and sequencing the order that they want to help progress students through so that they're getting to efficiencies and they're able to really connect the learning that they want them to do for that particular lesson. The curriculum is really heavily based in math discourse. That means that our students are talking in the classroom a lot. Um, if you're in the classroom, you're gonna hear a lot of conversations about math. You're gonna see lots of students sharing their thinking, both like in partnerships, but also across the room. And this is because we know that highly effective math teaching and learning includes student talking to each other. We want them to be able to explain their thinking. And we know that just because a student might know an answer, we really want for them also to be able to explain why you got that answer or explain why that works. And so those are going to be more of those rich, deep mathematical practices that span kindergarten through 12th grade for our students that we want to continue to strengthen, and that iReady really supports us in doing so through this discourse based model. So, part of that discourse based thinking, as I said, we really want students to know why something works instead of just knowing an answer. It's really important and strengthens the depth of their understanding around these math concepts and their opportunity to be able to transfer that knowledge to other problems in other math courses or in life. So, math manipulatives are a piece that are also deeply embedded within the iReady model, and also a strong part of what we know about highly effective math teaching and learning. So, when we think about the math manipulatives, those are really just objects or tools that allow our students to get more hands on, do some exploration to make sense of the math concepts, and it helps them to build some more visual representations or concrete representations that again then deepen how they understand some really sometimes complex math ideas. Sometimes they're not as complex in the elementary grades, but they get more and more complex. And so these are tools that help them to make sense of it, visualize it, and we know that that's all important ways that we become stronger as mathematicians. And so we're going to look a little bit at what these might look like in the 6A classrooms, what these look like in general. We're going to learn that you don't have to have anything special, really, even at home. Sometimes there are things around the house that you can use to help your students to really visualize and use some more concrete representations to think about their math learning. So, when we think about some different ways that we might use these, again, students can use this as a concrete representation of how they're solving a problem, whether that be through objects or visualizing that through pictures. We might see students counting, sorting, or grouping. And we know that as parents, we've seen that before our kids even started in school. Kids are counting things, sorting them into similar groups. And all those are building on strong math learning that's going to move them forward, but also things that we don't have to teach them necessarily. Our students are naturally using those math skills from a very young age. It does help to support a really deep number sense and really thinking about the relationships between numbers and how I can really quickly see the number 19 and I think about 20. Right. So I know you can kind of see that the two tens frames in the upper right image here. I know that my students, as they develop this visual model at a very young age, when we use 5, 10, and 20 frames, that relationship between 19 and 20 is going to really help them when they are needing to do more complicated computations with larger numbers. And that visual model can support that and develop that number sense and relationships among numbers. They're able to really construct math models and using real life situations or what a problem gives them and really start to build it out and think about what that really looks like. They can represent different amounts with different tools or manipulatives they might use. We're going to watch a really short demonstration of how you might use fraction strips as a tool or a manipulative that students can access, and also thinking about a manipulative that we all have, maybe less and less in the more electronic world, but thinking about money. and using those as a means to visually see when we're counting money, or sorting coins and things like that. Again, as I just shared, you're probably thinking, well, yeah, a lot of these things are sometimes very simple. And so if your students are working on counting some pieces or needing support with some basic facts or some things that they're trying to shore up on from their elementary years, you can use things like paper clips, or you could use cotton balls from the bathroom. You could pull out forks. It doesn't really matter, but it really is getting those hands-on pieces for students to be able to use in order to be able to manipulate something that is concrete, to be able to think about their math computation that they're working on. So these are some at-home options that you could use. I was thinking around, like, even the idea of thinking about multiplication, and if that's an area of fluency that your student might need to work on and continue to strengthen as they grow in math, you might grabbing the trying to understand multiplication, and so you're maybe looking at, okay, let's start small. What does it mean when we're looking at something like 3 times 4? And really checking for understanding, that they can understand that that is 3 groups of 4. And so if I can grab 12 cotton balls from my bathroom, or whatever that might look like, those 12 objects, and I can place those groups. I can create 3 different groups of 4. My students start to really see and visualize what that looks like, and understand when I write symbolically 3x4, 3 times 4, that that looks like this. I can then also quickly see, like, okay, well, I can count by my 4. So I know that's 4 plus 4 is 8. If I add 4 more, I have 12. And so it's going to help to build all these different connections for students, that's going to eventually strengthen something like fluency for that particular example of bringing in some more concrete objects, to practice their mathematics. But you can see on here, there's just lots of different ways that you could create things at home. You don't need anything special sometimes to use manipulatives to support your learner. So when we are thinking about mathematics, I think we have learned a lot around mathematics, and I know that the knowledge and the research right now is different than when I was a student in K-12 education. And so when we were practicing things, it was very much symbolic. So I was memorizing different algorithms. I was able to do long division, right? It was some of those things that I was memorizing and doing, that symbolic work, but not really understanding the other aspects of it. And so we know that if we want our students to be strong mathematicians, that they need to be making connections among all these different ways that math can be represented. So we do have the symbolic, and we are going to see numbers and equations and variables and have to manipulate them. But it's also important, and manipulatives help us to build on this, to ensure our students have the language to be able to talk about their math thinking, and to be able to have critical arguments with their peers around the strategies they're using and what's most effective, that they can contextualize the math that they're doing and think about, when would this be appropriate? When would anyone ever use scientific notation, right? So thinking about those pieces, using the concrete objects for that physical aspect of mathematics. So that's where, again, some of our manipulatives really show up strongly in that aspect. And then as well, the visual. So as we'll see next, oftentimes students will start with the physical and the concrete items, and then be able to more easily move into the visual. So now I can use that understanding that I have with these objects, and I can move that into, I don't need them anymore because I have it in my head, and I can actually draw out something similar to support me. And some things I don't need those objects. I can draw them out anyways. So, what this is, what I was just alluding to, was really thinking about how we move students through this idea of concrete mathematics to more representational. So, where they're able to draw it out and then getting them to that abstract. So, where they don't have any objects, they are just able to write. The equation and solve it. So you can see on these pictures on the right-hand side, right, we have 3 red clothespins plus 2 more. That is one concrete object students could count. We've got the counters, and then we just have the symbolic on the top, the 3 plus 2 equals 5. So we're wanting students to build towards that abstract with really strong base. It's visualized as this triangle. We want that strong base of concrete, and ensuring that their conceptual understanding, knowing why something works, is really strong as they move through there. Make sure I don't have anything else on here. What happens when our students are moving through this, or just having an experience like I had when I was in high school math, and we're only practicing algorithms, or looking at the symbolic aspect of mathematics, you start to see math as this. There's this list of magic rules that I have to be able to memorize, and I have to be able to do them really quickly. And that's what makes me good at math. And so this research helps us to think more broadly around what it looks like to be really strong in mathematics, and to have both that ability to do things abstractly with our math symbols, those traditional things we think about, but also to really understand the conceptual understanding, why it works, show how it works, and know what strategy to use when in a given situation. So, continuing with really ensuring we have a strong understanding of why these manipulatives are so important, we talked just at that last slide about that CRA instructional sequence, and making sure our students have that strong base, so they don't think it's just special rules that they have to memorize, that they really can think like a mathematician, and use a variety of different ways. We also know that math anxiety, there's been a lot of research recently around math anxiety, that does stem from this idea that I have to hold so many what feel like abstract ideas in my head, to be able to compute these problems. And so the manipulatives, the power of having those hands on objects, really helps us to sort of put that into play in front of me on the table. And so I get to take away a little bit of that mental load, so that I can really think about the concept, the math concept that I'm working on right there. So for students, instead of having to just imagine in your head or look at a numeric symbol about what happens when you're borrowing 10 in a subtraction, if you guys remember doing that, where you have to borrow and then you have to add it to the other number to do that algorithm, you can physically have our students using unifix cubes or little linking cubes to break apart and really think about that tens rod as 10 ones. And that helps students to really, again, take off some of that mental load and really start to visualize what's happening with these numbers and the relationship between them, so that they can strengthen their ability to do that without manipulatives eventually. We know that the manipulatives also often gives kids immediate feedback as they're using those tools right in front of them. And so they're able to see when things don't make sense, make corrections on their own. And so that's really powerful for them, as they're working with manipulatives, and not having to necessarily always wait for someone to tell you that the way you're thinking is off. Like, you can actually see it. Our manipulatives are also helping our students to use these and create these mental images as they're using the objects. It then starts to build into their memory. So when we think about wanting our students to not need manipulatives, having them and then building off of that so that they can already have those mental images because they've been building it is really going to help them to recreate some of that they had when they saw it, and then really strengthen that number sense, and be able to be more flexible with numbers when they are just looking at it in traditional numeric form. And then finally, if you have a student, maybe your child really prefers or benefits from that hands-on, this manipulative use really helps to engage more of our learners and show the different strengths that some of our learners have that doesn't show up when we have a more narrowed lens of math is when I do things fast and I'm really good at memorization. This is allowing and opening up for all of our students to be able to use a more kinesthetic element of the way that they learn. And it helps for us as the teachers and for our peers to really hear different ways of thinking about math, that often really solidify what they mean, what that conceptual understanding is for students. So let's take a look at what it could look like. And so I'm going to show you this short video, and this is algebra tiles. So you probably are having or seeing your students practicing, solving equations and things like that. When they're looking at middle school, doing some various things with algebra tiles might be something you hear them talk about. And so we are going to just watch briefly, like, what does that really look like and what does that mean to use manipulative in a middle school setting? What does algebra tiles look like?
We're now going to look at solving equations using algebra tiles. Now, in order to be able to solve equations with algebra tiles, you need to have a good understanding of how to add, subtract, and make zero pairs with algebra tiles. If you haven't done so, please watch the videos on those skills before watching this video. Let's look at the problem x plus 3 equals 8. First, we'll model the expression x plus 3. And set it equal to 8. Now, my goal is always to isolate my variable. If I want to figure out what x must be equal to, I have to get it by itself on this side of the equation. So in order to keep my equation balanced, anything I do to one side of the equation, I have to do to the other side of the equation. So in this instance, if I wanted to remove 3 positive tiles from this side of my equation, I have to also do it from this side of the equation. And I can do that as long as I do the same exact thing to both sides. So now I've isolated x, and I can see that x is equal to 5. Let's look at another example. Let's look at the equation x.
So hopefully that gave you a little idea if you're hearing your students talk about algebra tiles. That's a tool that they're using not only in middle school, but also can be a great set of manipulatives in high school. So maybe something that you hear about your student using or benefiting from. I've seen students also make these on paper. So if they're working at home and they want to just build them without having these sort of three-dimensional algebra tiles, they can build out on paper what an x, a 1 unit tile, or an x squared, depending on what they're working on. Another
Welcome to Math
way
with Mr.
that
J.
especially if thinking about middle school students, is fractions, right? So fractions and ratios and really understanding those concepts are really an important piece as our students are moving through middle school mathematics. And fraction strips really sort of have been amazing for our students to learn and see the relationship among fractions or parts of whole. So instead of always just like memorizing, the way again that I learned, maybe you learned as well, and just understanding I have to get a common denominator, or if I'm dividing I flip and multiply, all these again sometimes what feel like magic rules, helping kids to understand through fraction strips. And so we're going to just watch a little bit about what that looks like.
In this video, I'm going to cover how to find equivalent fractions using fraction strips. Now remember, equivalent fractions are fractions that represent the same amount. They represent the same part of a whole. In other words, equivalent fractions represent the same value. And then fraction strips are a tool we can use to help us when working with fractions. They help give us a visual of fractions. So let's use fraction strips to help us better understand equivalent fractions. Now here are the fraction strips that we are going to use in this video. We start with one whole, and everything is based off of this whole rectangle. Then we have the whole rectangle divided into two equal parts, so halves. Then the rectangle is divided into three equal parts, so thirds. Then four equal parts, so on and so forth, all the way down to 10 equal parts. Let's jump into number one, where we have two fraction strips, and we need to figure out the equivalent fractions here. We have 1/3 is equivalent to how many sixths? So as far as the top fraction strip, we can see we have one whole rectangle divided into three equal parts. Each part is 1/3 of the whole. Now only one part is shaded in, so this fraction strip is showing 1/3. So we have 1/3 written out right here. For the fraction strip underneath, the whole rectangle has been divided into six equal parts. Each part is 1/6 of the whole. Now, two of the parts are shaded in, so this fraction strip is showing 2/6. Now notice, and this is really important, each fraction strip is representing the same amount of the whole rectangle, the same part of that whole rectangle. Both have the same amount shaded in, even though we have different fractions here, 1/3 and 2/6. These are equivalent fractions, and the fraction strips help us see that. Moving on to number two, we have 1/2 is equivalent.
All right. Well, we're not going to keep going with that. But again, wanted to give you an idea of these tools or objects or visualizations that are supporting our students and strengthening their conceptual understanding of something like fractions. And so, fraction strips is something that we're using and utilizing as your learner is engaging with those middle school standards. In addition, this is just a snapshot of a Unit 5 from one of our middle school grade levels in iReady. And you can see within those lessons, again, a lesson is about a week. These are the different manipulatives that our students are using to be able to strengthen their understanding as mathematicians and to be able to broaden it past just a symbolic or procedural ability. So I just wanted to give you a snippet of how much they're being utilized to support our learners, and we were able to get those manipulatives so that we are ensuring access for all kids in every classroom because they are such an integral part of highly effective math teaching and learning, and they are embedded into iReady as a resource for teaching mathematics. All right. So I'm gonna pause now, see if there are any questions I can answer. And also, I do have a brief survey. Just I'm going to be sharing this out with anyone if they watch the sessions afterwards with the recording, or if they were able to join live. If these have been beneficial, if you would like to see more of these, and maybe what you'd want those topics to be. So I'm gonna stop recording and then just open it up for any questions and conversation that you'd like to have today.